Hey everyone, this is Mr. Ference, and today we're going to be looking at scientific notation, which is a convenient way of writing very large or very small numbers, which is something that we see pretty often in physics. So let's take a look at some of these numbers. To start with, the distance from the Earth to the Sun. We're measuring this in meters because this is a science class, and the distance happens to be, on average, 151 billion meters. It's a very large number. It took me time to write that out. I had to keep track of how many zeros I was dealing with. And likewise, the mass of an electron is even smaller than that. Again, we measure this in kilograms because this is a mass, and this happens to be this many kilograms. It's incredibly small. I mean, it's an electron, right? Of course it's small. I had to stop and count out every single zero. I probably messed up. I may have missed or added in an extra zero. But scientific notation fixes all of that. It makes our jobs as physicists so much easier. So scientific notation, the way it works is that you have this sort of format of writing it. You have some leading number n times 10 to the exponent. We'll just call it a. Well, there are a couple rules here. The number n, that leading number, must always be between 1 and 10. It can be 1, but it can't be any smaller, and it can't be 10 or larger. This exponent a can be positive or negative, and it's just a measure of how many places you have to move the decimal. So let's look at these numbers and rewrite them in scientific notation. This distance from the Earth to the Sun, our leading number has to be between 1 and 10, so it becomes 1.51. Now the decimal in the original number, I didn't write it, but it's right here after the last zero. And so to move it from here after this last zero to between the 1 and the 5 here, we have to move it 3, 6, 9, 10, 11. So that becomes 10 to the 11th power. And that is the same number. These are exactly the same number. They are identical. But writing it like this is a lot easier. It saves us time. It saves us brain work of trying to keep track of the number of zeros. And even more so here with the mass of the electron. Again, our leading number has to be between 1 and 10. So in this case, it's going to be 9.1. Now here we're moving the decimal. We're going to move it a total of 31 places, but we're moving it in the other direction. So it's not 10 to the 31. It's actually 10 to the minus 31 power. But again, this is exactly the same number. We're just writing it slightly differently. This is, like I said, it saves us time. It saves us brain work. The way to do this in the calculator. So if you're writing this by hand, the way I've written it is how it's written. If you're doing it in the calculator, there's actually a button or two buttons that you can press to do it. I really, 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 really recommend that you get comfortable working with scientific notation in your calculator. On the TI calculators, like the TI-83, 84, the way it is there's a second, you press the second button, and then you press the comma button, which is just below it. It'll say like EE. So the way that you would write it is you would say this would be 1.51 second, comma 11. So the leading number, second comma, and then the exponent. And what that'll end up looking like on the calculator screen itself is that it'll just show up as E. Again, this is exactly the same thing. So here on the left, this is how humans write it. Here on the right, this is how machines write it, how calculators and computers write it. Now, so if you see something like this on your calculator, you know that that's actually this, which is actually that. If you're doing the Google calculator, you can just type the letter E, and it does that as well. If it's something like a negative exponent, it's the same thing. You would just add a negative number, or excuse me, a negative sign right before the exponent. So this would be 9.1 e negative 31 kilograms. These are all the same thing, but these in the boxes are going to be a lot easier for us to work with as we're studying physics. I really encourage you to get comfortable working with it on the calculator. We'll keep practicing. And a common question is whether, like, if you write this on your work, is that okay? Your math teacher would say no. A very fussy, picky physics teacher will say no. I don't care. They're the same thing. This is generally the preferred way to write it. I'm going to tend to write it this way. But if you turn this in, okay, cool, whatever. They're the same thing. They're going to be equal. So let's take a look at a few more examples just to get practice. And then you'll go ahead and work on your own. So 76,300, again, that leading number between 1 and 10 becomes 7.63. We count how many times we move the decimal. So we moved it from here, 1, 2, 3, 4. So that's times 10 to the 4th. This one here, our leading number between 1 and 10 is 6.6 times 10. Now this is going to be a negative exponent, because we're moving it the other direction. 1, 2, 3, 4, 5. And yes, I have a degree in physics, and I've been teaching physics for 6 years, and I still have to like individually count. So it's fine. You're doing fine. 872, our leading number becomes 8.72. We've moved this 2 decimal places, so it looks like that. And then 5. Now this one's a little trickier. Our leading number is between 1 and 10, which is 5. But hey, we don't have to move the decimal at all. So in scientific notation, since we've moved the decimal 0 places, this is 10 to the 0. Now remember from math class that anything raised to the power of 0 is just 1. So this is actually the same thing as 5 times 1, or just 5. Okay, so that's how we do scientific notation. Just keep practicing. And again, let me know if you have any questions. Good luck.